The sun is a ball of fire. It looks like fire, it glows, it gives us sunburns when we go to the beach, so it must be fire, right? But it's not. Fire is a chemical reaction. Things like wood or gas reacting with oxygen and releasing heat and light. The sun, it's nuclear fusion. The sun squeezes hydrogen atoms together so hard that they fuse into helium, releasing an absurd amount of energy. This all happens in the core, under insane pressure and temperatures of around 15 million degrees Celsius. And hydrogen is just the beginning. When the sun gets older and starts running out of hydrogen, it'll begin fusing helium into heavier elements, like carbon. In short, the sun is a self-sustaining nuclear engine. But I hate to break it to you, one day that engine is gonna shut off. Estimates say it'll happen in about 5 billion years, which is around episode 260 billion of One Piece. Or if Rockstar keeps releasing one GTA every 5 years, we'll have 1 billion GTAs by the time the sun dies. The vacuum is completely empty. Yeah, not really. There's this thing in physics called the Heisenberg uncertainty principle. It says that you can't know exactly where a particle is and how fast it's moving at the same time. So even in what we call a vacuum, nothing can be 100% still. If a particle were completely at rest, with zero momentum, then its position would have to be totally undefined. Like, it'd be everywhere and nowhere at once. So physics just doesn't allow total stillness. That's why the vacuum isn't so empty. It's full of tiny fluctuations called quantum fluctuations, small jitters that make particles form and disappear super quickly. These are called virtual particles. Nerd stuff. Yeah, maybe, but this actually affects the real world. Even two metal plates placed extremely close together will attract each other, even in a vacuum. At absolute zero, everything is frozen still. If you understood the last topic, you might not even need this one. But hey, let's go over it anyway because it's cool. We tend to imagine that at absolute zero, which is negative 273.15 degrees Celsius, everything just freezes in place. Like particles hit the brakes and stop forever. But not quite. Once again, Heisenberg's uncertainty principle steps in. So even in the coldest corners of the universe, particles don't stop moving completely, which brings us to a concept called zero-point energy. Basically, even if you remove all thermal energy from a system, there's still a tiny quantum leftover, like that buzzing in your headphones even when the music's paused. That leftover energy is always there. So yes, even at absolute zero, quantum mechanics is still doing its invisible little dance.